Okay, and welcome back. In this video, what we're going to do is first, we're going to talk a little bit about what kind of data we're actually using. So we're actually using both LAS and LAS files eventually. And what that means is these are LiDAR formats that are, typical. It's open standard. The LAZ format is sort of a compressed version of it. Now the LAS and the LAZ formats are open standard for point cloud data files established by the American Society of Photogrammetry and Remote Sensing, ASPRS. Um, the beauty of the LAZ file is that you don't actually have to uncompress it for the programs to read them, which is really nice. Now, for our discussion here, um, there's two versions of the classifications, 1.1 and 1.4, and there's some in between. But the idea is that what we're eventually going to do is sort of pluck out just the bare earth or ground points. We don't need the tree tops, we don't need the building tops. So what you see on the screen here is the current standard, the older standards here, the 1.3 version, and then the newer standards, which just means they're adding some specific standards, things like rail and road surface and wires and stuff like that. But for our purposes, what we're eventually going to do is just use the ground or classification number two, because all we're doing right now is just visualizing this data as a topographic feature. We're not going to be extracting building heights, we're not going to extract tree canopies or anything like that. So I bring this up now because when we get to the point where we're actually going to run the program in PDAL, you have to understand which points you need, and it's within a range of coding values. For our purposes, we only need code 2. Okay, so now that we talked a little bit about the data that we're going to use, these are point clouds that get really, really big. Let's go ahead and start jumping into Anaconda itself. To do that, you have to go to your start menu and find your Anaconda. Mine's right here. I have the 64-bit. And what we need is the Anaconda PowerShell prompt. So go ahead and open that. Oh, let me bring it over to my other screen here so you can see it. I'm going to make it full screen just because it might be a little hard to read that. When you first installed Anaconda, unless if you really knew what you're doing, which I really didn't, I just accepted all the defaults, you had the opportunity to change the name of your environment variable. What that is that's telling the program, okay, here, use these settings for my purposes. So in the directions, it has pdal env. Mine stayed as just my env, which is the default. Now, in order for PDAL to work and for the program to understand what we need to kind of call or activate PDAL within Anaconda, and that's super easy to do. You just type in conda, CONDA, space activate, and then the name of the environment variable you have. If you didn't touch anything like me, you just sort of installed everything, it's going to be MyENV, MYENV. Now you'll notice before the right here, it went from base, I don't know if you can see that or not, base way up here in the corner to my ENV. So now the program understands where the settings are and we can go forward from there. The next thing we want to do is we want to see what options we have within PDAL in Anaconda. And to do that, we're going to look at the help menu. And this is very common for a lot of command line programs. If you type the name of the program, a space, and then dash H, it'll show you all the commands available. So I go pdal space dash H, hit the button, and now we have a list of commands and some of the other um, usage. That's very common in both Unix, Linux, and DOS world, I guess, to use an old term. The only one of these that we're actually going to use is what's called the pipeline, which is right here. Pipeline, what that does is it allows us to use an external JSON file to run essentially a script. Now, JSON stands for JavaScript Object Notation. I am not super familiar with this, but when you look at the code, it's pretty easy to understand what's going on. We'll look at the code in a second. It's a lightweight format used for storing and transporting data. It's very fast. A lot of times it's used to store and transfer data to websites via, over IP addresses and things like that, servers, internet servers. So for the purposes of this exercise, we're just going to string together a few tools, a few commands to get the job done. Now, could you do these separately? Probably, but when you're doing a lot of command line type work, Unix, Linux, whatever, automation is the key to everything. So you want to learn how to write scripts like this. I wrote a 10-page script to automate most of my earthquake uh, stuff. So when a notable earthquake occurs, it literally takes me 10 seconds to run everything, and I get all the data back I need, including the maps that I need generated. So it's really nice to be able to automate things, and that's what the pipeline tool does. So now what we need to do, you could technically run this from this directory, from this folder structure, but I find it's a lot easier if you go into the folder where the actual data and the script, the JSON script is. Okay, so I'm going to give you a crash course in sort of folder directory structure. So if you can see on mine, I'm in the directory on the C drive users bketter. So when that's a Windows thing where, that's sort of your space on the computer. Now, what I need to do is go figure out where my JSON file is, and you need to do the same thing. Now, our JSON files are going to be in different directories. I'm just going to kind of show you the two little commands that you can use to do this. And one of them is CD, which stands for change directory. C is in cat, D is in dog. So but first, and it tells you right there where you are now. So you can actually go up a level or down a level, and I'll show you how to do that. The other uh, command is dir, which stands for directory. So I'm going to hit dir and then enter. Oops, not dit, dir, and it tells me everything that's in there. Now I know where my files are. My files are sitting on a folder on the desktop. So I need to get to the desktop first. I type in cd space desktop and hit enter. And I'm going to use dir again. Okay, so now it tells me everything that's on my desktop. It's a little messy right now. So I need to get into the PDAL LiDAR folder here. That's where my stuff is. Again, your path is going to be different. I'm going to go CD, P. Now, there's only one directory that begins with the letter P. I can use my tab button and just it'll automatically fill it in for me. Hit enter and type dir again. Okay, now I have all kinds of stuff in there. You will not have as much as that. This is sort of my testing directory. So now what we need to do is the next step is to run the pipeline. But before we do that, I want to explain to you what the pipeline is. So go ahead and get into your directory, and then I'm going to pause this here, and I'm going to restart with the JSON file. Okay, so I opened a folder where my JSON file is sitting. All right, I put Anaconda aside for a minute because we want to take a look at the JSON file so we can see what's actually going on there. So you should have the JSON file, and I supplied it to you. Plus, it's on a link in the tutorial. So my JSON file is sitting right here. I kept it right to the tutorial of Paulo's, and I call it pipeline.json. Now I have Notepad++, which if you don't know this, if you do a lot of GIS, it's a great program, especially for things like rasters. It'll open almost any file you can imagine, even if it's binary and a bunch of gibberish. Notepad++ will open it. I love it. Go get it. It's free. Anyway, no, I'm not getting paid for this sponsorship. So I'm going to right click on my JSON file because Windows is not going to know how to handle that kind of file. I'm going to go to edit with Notepad++. If you don't have Notepad++, you should be able to open it with either WordPad or Notepad. It doesn't matter. Okay, so I'm going to go ahead and click edit with Notepad++ and open this file. And I'm going to minimize this background here so you can see it a bit better. All right, so this is the JSON file. Now I've already changed my paths. Okay, so you have to do the same thing. So wherever you changed, or excuse me, wherever you saved your LAS file that you downloaded or that I gave to you, you need to change your path to where that is. Now let me show you a trick on how to do that. If I go back over to my folder, if I right click up here, see I'm in the PDOL folder right here. If I right click on this, I can go copy address as text and then I can paste it in here. I'm going to paste it down here just so I don't mess up mine because I want to show you something. If I paste that in there, it's okay. It's really ugly, but there it is. Now you'll notice those are all backslashes. Okay. Now that's really hard to read. I apologize. Let me undo that. Let me do it in here. See if it'll let me do it. Yeah, it's still bad. La la la. There. Okay, hopefully you can read that a little bit better. Now you'll see the difference. The red one is correct. You have to change all of the slashes to forward slashes for this to work. Um, that's just a Windows thing. All right, and then you have to make sure the last part of your is the actual LAS file. So here's the path, which I just copied and pasted. If I add a forward slash and then just type in the name of the file, which should be the same is what you see there. So I just want to show you, make sure you have all forward slashes on yours. I'm going to delete this, otherwise we're going to get an error. Okay. And now I'll explain what's going on in this particular file. So this is the JSON format, which is basically a bunch of curly brackets and nested brackets that is a quick little script that'll tell PDOL via what's called a pipeline. Now, pipeline allows us to, that's the tool within PDOL to allow us to do this type of scripting. So first thing we got to do is we need to activate pipeline, okay? And that's what this is. So it's telling the program, hey, use pipeline with the colon. Now everything after the colon with the bracket from here all the way down to here is what's going to be run by pipeline. So the first thing we need to tell it is where the data sits. And you'll see this comma right here. That comma tells the program there's going to be more going on. There's going to be more, what do you call it? More commands coming. Okay. And so that tells it that the next step is a processing step, excuse me. So the comma after line lets pipeline know that the next step is a processing step. Now the first thing we need to do is declare the filter type, which is a range. Now, if you don't do this, you'll get back sort of all of the data. Now, what we want to do is we want to tell PDOL that we don't want all of the data. We're just going to use a range of codes. So that's what that filter means. The next the next processing step is going to be a range of codes. Now that's what this is. So we're going to use a range of codes with the classification here. So within the point cloud, the, the it's keying in on the word classification, saying, okay, which classification code do you want? And I showed you that image earlier of the different classification codes within the LAS classification scheme. For our purposes, all we want is bare earth. So because we only want one, that's why there's a 2:2. We're starting and stopping with 2. We could, if we wanted more back, let's say we wanted a larger range and more data back, we could do 2-4, for example. We don't want that. We only want ground points, so that the range is strictly just 2. We only want 2. We're going to start with 2 and we're going to stop with 2. Okay, so that is so far what we're doing. We called pipeline, told it where the LAS file is, tell it that we're going to use a range of values to get back. We told it what that range is based on the classification scheme, and all of that's been processed. That's what within these curly brackets here. Now this comma here, right here, tells us, okay, that's the end of that particular. The next step is another processing step within this set of curly brackets. Okay, now what we need to do is we need to define the output of the PDAL. First of all, we want to give it a name. Again, we give it the entire path. Where are we going to save the output? We're going to save the output in the same folder and give it a name. And right there, you can see it's going to be a TIFF file. However, even just because I put .tiff there, that doesn't mean anything in the sense that we actually have to explicitly tell the program what the format is. We're just adding the extension there. So now we have another comma saying, okay, here's another processing step. We're going to use the GDAL driver. Okay, so the GDAL driver defines the output format. We want a GeoTIFF. That's what we're going to get back. That's why we put the .tiff on the end here. So the GDAL driver says there are other formats that you could use, but we want a GeoTIFF, and we want output type to be all. Now, there are other options for that, such as you could get back just the minimum values, the maximum values, the mean values, the IDW or interpolated values, just the count or standard deviation. We want all of that. We're just going to grab it all. Now the resolution is 5 meters, and that is based on the fact that the coordinate system is meters. So if you're using meters, that's going to be in meters. If you're using feet, that would be in feet. And then finally, the type is sort of explicitly telling it how to output this particular data. Because we're using, excuse me, we're using GDAL to create this raster. So GDAL is sort of the umbrella of tools being run in the background to create the raster. PDAL allows us to run the script and to utilize those tools. GDAL is the overall umbrella library that's actually creating the output raster using an interpolation. So there's other different types of writers. Um, I went and looked up all the documentation for PDAL, and it's very nice and easy to understand. The only one I had a little bit trouble figuring out was the I forgot which one it was, but one of them was a bit tricky to find. I think it was the type one. Um, or the output type, excuse me. The output type took me a couple minutes, but now I understand it. So it's pretty straightforward. You give it an input, you tell it what data you're going to pluck out of it with the range and classification, and then define how you're going to save it. And it's pretty easy to understand, even if you don't do a ton of coding. So now what we're going to do is we're going to go back over to Anaconda, and we're going to run this thing. All right, so now we're back in Anaconda, and because we changed into the directory where the JSON file actually sits, running this particular code is super easy. All you do is type pipeline. Oh, excuse me, I apologize. You type pdal, you have to tell pdal. pdal pipeline, and then the name of the file, which is pipeline JSON. Okay, and I just hit the tab button there. So pdal space the word pipeline, which is, that's we're calling that, and then the pipeline allows us to run a script, and then the JSON file associated with it. All right. Now this could take a little bit. This is a pretty big file depending on your computer. So, and you won't see any type of anything on your screen to let you know what's going on. Either it's going to work or it's going to bark at you at some point. So we're going to go ahead and run this. Uh-oh. Oh, I think I changed directory. Give me a second here. Okay, let's try that again. I forgot I had moved the last file into the folder that I was going to share with everybody, and instead of making a copy. So we're going to try that again. If my and let's go ahead and try that again. So now it could take a couple minutes. I'm going to pause the video while this goes because I forgot how long it takes. It's not super long, but I'm going to pause and I'll be back when it's done. Okay, so after about 15-20 minutes, my dtm.tiff file was finally done. And you can see it here. I did it twice actually just to make sure everything was working right. And it's about, what is that, 360 megabytes or so. So the next step now is to close down Anaconda here. So we've built our raster. Now we have to bring it into QGIS, project, give it a projection, and then visualize it, see what it looks like. So the next video will be in QGIS.